All right, so here we have a plane flies 435 miles with the wind and 345 miles against the wind in the same length of time. Now, if the speed of the wind is 15 miles per hour, find the speed of the plane in still air. Still air. So, okay, so what we have is we're going to kind of do like we did before with the boat. The wind is blowing this direction and it's going 15 miles per hour. So when we go against the wind, it's going to be our rate. So let's say x is equal to the speed of a plane. So then this is going to be x minus 15. And then we go with the speed, it's going to be x plus 15. Now, against the wind, it can only go 345 miles, but with the wind, we can go 435 miles. Okay. And again, time is equal to the distance divided by the rate. So since the times are equal, we can just set those two proportions equal and we should have the answer. So 345 over our rate of x minus 15 is equal to 435 over our rate, which is x plus 15. Now, again, I'm just going to do cross product. So I'm going to get what? 345x plus, and then if I do that on my calculator, 345 times 15, 5175 equals 435x minus, now 15 times 435, 6525. Now I have to solve for x, so let's add 6525. Let's add 6525. Now let's subtract 345x, subtract 345x. So those cancel, those cancel. What do we get here? It looks like 90x, and that's going to be 5175, 11,700 divided by 90. And so x is going to be the speed of the plane, and if we divide that by 90, we get 130 miles per hour for the speed of the plane. Okay, and so that would be our solution to this problem. Again, setting up a graph or a table or a picture is easiest way. I like pictures myself, so kind of whatever works for you. This is the way I like to look at it, and it makes it work for me. So then I just have to know that what the equation is: distance equals rate times time. The times are the same, so I solve for time, and then just take distance divided by rate, and then I can solve for my x. All right, here, every weekend you ride your bike on a forest path reserve preserve path. It's 24 miles long and ends at a waterfall, at which point you relax, then make the trip back to the starting point. One weekend, you find that in the same time it takes you to travel to the waterfall, you're only able to return 20 miles. Your average speed going to the waterfall is 2 miles per hour faster than the return trip. What was your average speed going to the waterfall? All right, so what we have is we have some kind of a path we're going along. And this way, our distance is equal to 24 miles. This way, our distance was only equal to 20 miles. Okay. Now, our rate here going to the waterfall was equal to what? Well, it was equal to our speed of our bike. So this is going to be x equals the speed of bike on average. And it's going to be what? Well, it's going to be plus 2. And this one is just going to be rate is equal to x. Okay. Now those times are going to be equal again. So our time is equal to distance divided by rate. And so our distance was 24 over x plus 2 equals 20 over x. Now we solve for x. So we do cross product. We get 24x equals 20x plus 40 minus 20x. 4x equals 40 divided by 4. So it looks like x is equal to what? 10 miles per hour on the return trip. But what they're asking for is x plus 2, so that's 12 miles per hour going to the waterfall. So this is the number they're looking for here. So when we solved it, we get the x is equal to 10 But that's the return trip speed. And what they want is what was their average speed going to the waterfall. So we have to add 2 miles per hour because that was going. And so that was the 12 miles per hour going to the waterfall. All right, so let's stop there and come back for some more.